The interstellar comet known as 3I/Atlas has captured the attention of scientists around the world, not only because of its rarity, but also because of the extraordinary opportunity it presents to learn about the building blocks of distant solar systems. This comet, which reached its closest point to the Sun on Wednesday and Thursday in an astronomical event known as perihelion, has provided researchers with exceptional conditions to observe and analyze its composition. What makes 3I/Atlas especially remarkable is that it is only the third confirmed interstellar comet ever detected, meaning it does not originate from our solar system, but instead comes from somewhere far beyond, possibly ejected from a star system that formed under completely different physical and chemical conditions. Its discovery triggered immediate excitement among astronomers, astrophysicists, and planetary scientists who rarely get the chance to examine material that has spent most of its existence traveling between stars. Jason Wright, a professor of astronomy and astrophysics and the director of the Penn State Extraterrestrial Intelligence Center, expressed this excitement clearly when he explained earlier this month that scientists are thrilled to have even one more specimen of such a rare cosmic visitor, because it can help them understand how comets in other solar systems compare to those that formed alongside Earth. The comet was first detected on July 1, 2025, by the NASA-funded Atlas Survey Telescope in Rio Hurtado, Chile, a project designed to identify possible asteroid threats, but which has also proven powerful in spotting faint, distant, and fast-moving objects. Shortly after discovery, the object received the official name 3I/Atlas. The 3I indicates that it is the third identified interstellar object to enter our solar system, following the mysterious cigar-shaped object 1I/Oumuamua and the comet 2I/Borisov. Atlas, which stands for Asteroid Terrestrial Impact Last Alert System, was not originally designed specifically to hunt for interstellar comets, but its wide-field scanning capabilities and constant monitoring of the sky allow scientists to detect unusual celestial bodies long before they pose any potential hazard. With 3I/Atlas, NASA quickly confirmed that the comet poses absolutely no threat to Earth. The agency explained that the object will never come closer than approximately 240 million kilometers to our planet, a distance so large that it eliminates any conceivable danger of impact or even gravitational influence. Despite its safe distance, 3I/Atlas has generated widespread public and scientific curiosity. Some people hoped that an interstellar comet passing near the inner solar system might be visible in the night sky, offering a rare and beautiful sight. However, NASA and various observational teams clarified that the comet is too faint to be seen without a powerful telescope. Between July and September, it could be faintly observed through large observatories and advanced telescopic equipment, but as it approached the Sun, its visibility dramatically decreased. The Sun's glare made the comet nearly impossible to detect from Earth's surface as it moved through the brightest part of the sky. This is a common challenge in observational astronomy. Objects that pass near the Sun become lost in its overwhelming brightness, requiring astronomers to rely on space-based telescopes or wait until the object moves into a darker part of the sky. Fortunately, astronomers will not have to wait long. By early December, 3I/Atlas will begin moving away from the Sun's blinding vicinity, re-entering a region of the sky where telescopes can once again locate and track it. When that happens, it will become visible again from the northern hemisphere, allowing astronomers to collect additional data on its brightness, tail formation, dust release, and chemical signatures. The comet's closest approach to Earth will occur on December 19th, a moment many observatories are preparing for with great anticipation. Although 3I/Atlas will still remain extremely distant, about 1.8 astronomical units from Earth, it will be bright enough for sophisticated instruments to study. For comparison, 1 astronomical unit is the average distance between the Earth and the Sun, and 1.8 Australian dollars translates to about 170 million miles, or 270 million kilometers. While this is far too distant for the naked eye to see the comet, it is close enough for research teams to gather valuable scientific measurements. What makes interstellar comets so fascinating to scientists is their ability to serve as messengers from other regions of the galaxy. Most comets in our solar system originated billions of years ago in the cold, outer regions of the Kuiper Belt or the even more distant Oort cloud. They contain pristine material left over from the formation of our own sun, planets, and moons. But interstellar comets like 3I/Atlas formed completely separately and were later ejected from their home systems, possibly through gravitational interactions with large planets, collisions, or other dramatic events. As they drift through interstellar space over millions or even billions of years, they barely change, meaning they preserve the chemical fingerprints of their birthplace. When such an object enters our solar system, it provides a rare chance to compare how other planetary systems formed compared to our own. Scientists studying 3I/Atlas hope to detect differences in its chemical makeup that might reveal how unique or common our solar system's formation processes are. By analyzing the comet's tail, researchers can determine what types of ice's sublimate when heated by the sun. Comets are known to release gases such as water vapor, carbon monoxide, carbon dioxide, ammonia, and various organic compounds. If 3I/Atlas produces unusual combinations or ratios of chemicals, it could suggest that the environment where it formed was significantly different from the early solar system. If it appears chemically similar to local comets, that might indicate that many solar systems across the galaxy form under comparable conditions, strengthening theories about planetary formation patterns. Another aspect of scientific interest is the comet's structure and density. The way 3I/Atlas behaves near the sun, whether it breaks apart, remains stable, or jets material violently, can help scientists infer how tightly packed its materials are. Some interstellar objects, such as Oumuamua, exhibited strange accelerations and unusual shapes that challenged existing theories. Researchers hope that 3I/Atlas will provide cleaner, more consistent data that can be used to refine current models. Its brightness patterns, rotation, and response to solar radiation can reveal whether interstellar comets tend to be dense and rocky, loose and fluffy, or shaped differently from familiar comets. The interstellar origin of 3I/Atlas also inspires curiosity about its journey. Traveling through the cold, empty space between stars is an unimaginably long voyage. Comets exposed to cosmic rays, gravitational fields, and interstellar dust undergo changes that cannot be replicated in laboratory environments. Every interstellar comet that enters our solar system brings with it a fossil record of cosmic history. Researchers wonder how long 3I/Atlas has been traveling, which star system it might once have belonged to, and whether traces of its origin can be detected. Although identifying its home star is extremely difficult, certain chemical patterns or trajectory clues could hint at the type of system it came from. Public interest in interstellar comets has grown significantly in recent years, especially after the discovery of the first known interstellar object, Oumuamua, in 2017. Its elongated shape and unusual acceleration sparked debates about whether it was natural or artificial. The second object, 2I/Borisov, discovered in 2019, behaved more like a typical comet and helped calm some of the more exotic theories. Now, with 3I/Atlas, scientists hope to continue building a clearer picture of what interstellar objects are like. Each new discovery adds to a small but rapidly developing field of research focused on understanding how material moves between star systems and how frequently such objects enter our solar system. NASA and observational teams worldwide are already planning coordinated observation campaigns for December, when the comet becomes visible again. Ground-based telescopes, space observatories, and spectroscopy instruments will work together to capture as much data as possible before 3I/Atlas disappears back into the depths of space. Because the comet will not return, interstellar objects typically follow hyperbolic trajectories that carry them in and out of the solar system only once. This is a once-in-a-lifetime opportunity for scientists. They must gather every meaningful piece of information now, because the comet will likely never be seen again once it travels beyond observational reach. Even though the general public will not be able to view the comet without professional-grade telescopes, the scientific value of 3I/Atlas far outweighs its faint visibility. Its arrival reminds humanity of the vastness of the galaxy, the countless solar systems beyond our own, and the extraordinary possibility that material from distant stars occasionally passes through our cosmic neighborhood. For researchers, this comet is a precious sample of another world. For the public, it is a reminder that our solar system is not isolated, but part of a much larger and more dynamic galaxy full of wonders we are only just beginning to understand. The discovery of 3I/Atlas underscores how much remains to be explored and how every interstellar visitor brings new knowledge, new mysteries, and renewed curiosity about our place in the universe.